Hello, everyone. Thank you for joining us. We're going to give it just about one more minute here, and then we will get started. All right, we can get on started here. On behalf of the Environmental Finance Center Network, welcome to our webinar today on PFAS today, tomorrow, and forever. My name is Maya Bani from the Syracuse University Environmental Finance Center. And before we begin here, we're just going to go over a few housekeeping items and then we can get started. During the training today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you'll receive a follow-up email that includes a link to the recording and any other information you may need. You can also download the slides from today right now or afterwards in the Handouts tab in your GoToWebinar control panel. This session has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date, and if you have any questions or need assistance, please contact smallsystems@syr.edu. And now just for a little bit about us, the Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I'll be sharing shortly in the chat. And then on that note, we can get started. I would like to introduce our presenter for today, Will Shaffer, PE Project Engineer from EEC Environmental.
Thank you, Maya. All right, well, let's jump right in. Looks like we've got the presentation loaded here. So thank you, Maya. Thank you to the EFC Network for hosting me today to talk about PFAS. Just a little bit about what we're going to talk about, and I want to start here with a bit of a spoiler alert for those who may be new to PFAS. There's not going to be a ton of good news shared today. It's going to be a lot of technical information, and some of it may be alarming or just bad news in general, but know that there is some hope, some light at the end of the tunnel. I'll share some of those options with us. We're going to talk a little bit about an introduction to PFAS. There may be some people here who are new to PFAS, who've heard about forever chemicals in the news or heard about PFAS, but don't quite understand what that is. We'll go through a little bit of PFAS 101. We'll talk about regulations, where they're at today, where they are headed in the near future, and what regulations there may or may not be on the horizon as well surrounding PFAS. With those regulations, it's going to be important to understand how they impact all of us in our communities. The best way to do that is to characterize, to sample, to determine if there is an PFAS impact in our drinking water system, in our wastewater system, in the environment around us. We're going to talk about some ways to do that. And then once we do know what the impact is or is not, but if there is an impact, we'll talk about the treatment solutions available to us today and where things are headed as well on some emerging technologies. And lastly, we're going to touch upon some of those funding options, and I'm going to encourage you to also leverage your EFC partners, your local networks, to find out what some funding options may be available to you, but we'll touch on a few of those. So with that, we'll dive right in. A little bit about myself and about EEC. I'm a civil and environmental engineer. I'm licensed in 20 states throughout the US, and I've been working on PFAS for a number of years in a number of different ways. In particular, I am a PFAS owner's representative for a large water producer here in Southern California. I provided third-party technical review of the first PFAS local limit adopted in the nation. I provide training seminars like this to municipalities and industries nationally. So I touch on a lot of things around PFAS, both on the drinking water side, wastewater, and anything within kind of water resources or one water area. And then EEC, I'm a project engineer for EEC project manager. EEC Environmental, we're a national environmental consultant. We have a team of chemists, professional engineers, professional geologists, hydrogeologists, and then regulatory and environmental compliance specialists, all with that PFAS knowledge base that they are able to leverage in all that they do, from site assessment and cleanup to water treatment or wastewater treatment or anything in between. So that's a little bit about who we are and who I am in particular. And with that, let's dive right into what PFAS is. But before we do that, I want to kind of get a feel for who we have on the line here. Maya's going to put some poll questions up so that I can tailor what I talk about to those that are here in the audience. So the first question is, what is your level of PFAS knowledge today? Is it something that you're just starting to learn about? At the bottom there, I'm brand new to PFAS, or you're learning about PFAS but haven't really taken any actions around it yet. Maybe you've already installed PFAS treatment systems and this is old hat to you, you're an expert. Or maybe you're somewhere in between. You started planning, started installing these systems and wondering where things are going to go from here. So take a minute to answer those questions. Maya's going to let us know when we've got answers available.
Looks like almost everyone has answered, so I'm going to give about 5 more seconds and then I'll close the poll here. All right, 3, 2, and 1.
All right, so a lot of people are either brand new to PFAS or just learning about it, but haven't really done anything around it yet, which makes sense. We're going to talk about why that is with where the regulations are at. And then there's a few of us that have already, dipped our toes into it, or rather been thrown into the deep end of PFAS. And I'm glad we have those people online too to leverage that expertise. Next question for us, Maya. What is your role? I'd like to kind of understand who we have here on the line, whether you're a regulator, a water or wastewater treatment system or distribution system or collection system owner, or maybe you're an operator, or maybe you're an engineer or consultant advising these types of folks, or if you don't quite fit into any of those boxes, maybe you fall into the other box. Let's take a second to answer that.
All right, closing the poll here in 3, 2, and 1.
All right, about half the audience are on the regulatory side of things. We've got some system operators and owners in the house, maybe about a quarter of us, and the rest are engineers or consultants, and some that fall into the other category, maybe some technology folks out there that are looking at technologies around PFAS. So good mix here, heavy on the regulatory side, which is great. And then our final question here, I'd like to understand what you all are most interested in as far as PFAS goes. Is it PFAS in drinking water, wastewater, recycled water, stormwater, or is it something else? And I would put maybe impacted sites, contaminated sites, site cleanup in there, or air quality. We only had 5 options here on our polls, so pick the best option for you. Let's figure out where the concern is, and we can kind of tailor our discussion around that.
All right, closing the poll here in 3, 2, and 1.
All right, drinking water. And that makes sense, and we'll talk about why that is. That's where the greatest level of regulation is and where it's headed. A good bit of wastewater here as well, not so much heavy on recycled or stormwater or something else. And we'll see that lines up really well with what I was expecting, and because of where the regulations are at, why this might be the greatest concern. Also, there's the public aspect of this, news articles and the media, and it's mostly focused on drinking water appropriately. And we'll talk about what that is and why. So thank you. Thank you for your participation here in these polls. With that, we're going to jump right into this and start talking about what is PFAS. And in your polls, most of you said this is new to you, or you're just starting to learn about it. So I'll focus a little bit more on these earlier slides. I'm going to blow through some of the later slides, which are some of the more technical slides that get a little bit more into the weeds. But since this is something new to a lot of us, I do want to make sure that we got a good understanding of what we're dealing with here. So a little bit of 101 here on what PFAS is. We pronounce it PFAS. Some people have been pronouncing it PFAS, and I'll talk about why PFAS may be a more appropriate pronunciation. But PFAS is an acronym. It stands for per and polyfluoroalkyl substances, which is just a mouthful. So we keep it simple. We call it PFAS. And what this is, it's a broad range of chemicals. These are man-made chemicals that are used in all sorts of products, all sorts of consumer products, industrial processes. But if we boil it down, let's keep it simple. If it's something that is heat resistant, oil, grease, stain, or water resistant, most likely that's PFAS chemistry driving that. And these are very useful chemicals and therefore very ubiquitous throughout these consumer products and industrial processes. Looking back towards the 1940s and 50s is when production of these chemicals started and the application of them in consumer products, most notably Teflon lining of pans, cookware, non-stick liners of cookware, and then moving on from there, Scotch Guard or waterproofing for carpets, or you'll maybe look at old movies from the 60s, 70s, 80s, and you'll see them with their carry-out bags of food, and it's got all these grease stains on it. But then you go and order a pizza today, and you don't see the grease stains. All that delicious grease is kept in your pizza. That's most likely PFAS chemistry, the grease resistance there, the stain resistance. So these are very useful chemicals, and because of that, they have been used all over the place in all sorts of areas, and we'll talk about why that has become an issue for us as we've started to learn about the impacts of PFAS to our environment and to our human health as well. There are over 5,000 chemicals. It depends on who you ask and what database you look at, whether it's 5 or 10 or 15,000 chemicals that all fall within this kind of PFAS umbrella. And they all have, you know, alphabet soup names and chemical structures to them. There's two of most note, PFOA and PFOS, PFOA and PFOS. We're going to talk a lot about those two today. The reason being because those are the two most heavily regulated PFAS compounds currently and as we move forward. But PFOS and PFOA, I would recommend for those just starting to learn about PFAS to watch the movie Dark Waters. They do a good job. It's a thrilling movie, exciting movie, kind of this, you know, drama movie, law drama type of movie. But they do a good job at least of introducing what I've talked about, how PFAS was used, and what they call it C8 PFOA in that movie, and what PFAS is. And then you may hear it in and about the media and news called forever chemicals. And the reason they're called this is because they don't readily break down in the environment or in our bodies. These are very stable chemicals. The chemical structure of them is very stable, and so they don't break down. They persist. They also bioaccumulate in the environment. That means they don't pass through our body and they continue to build up over time within our body. So this becomes an issue for us, especially as we look towards how to treat for PFAS and how to destroy ultimately PFAS. It becomes technically difficult. One of the other things that I want to introduce to you is the terminology and an idea of what types of concentrations we're looking at for PFAS in the environment. And as we start looking at the analysis of this, some of us may be familiar with parts per million or milligrams per liter, whether we have MCLs, drinking water limits that we have to comply with that are in the parts per million range, or maybe parts per billion even, or parts per billion maybe on site cleanups. We're talking parts per trillion when it comes to PFAS, sometimes even parts per quadrillion. I want to kind of give an idea of the scale of this, and I think sometimes what's most useful for me, a lot of people say a single drop within 20 Olympic pools. I've never swam in an Olympic pool, but you might be able to see here, I am a Rams fan, LA Rams fan. I have been to SoFi Stadium, or pick an NFL stadium near you. If I were to put half a teaspoon of salt anywhere in that stadium, in any suite or under any seat or somewhere on the field or in the rafters, I told you to go find that half teaspoon of salt, do you think you'd be able to find it? Or how long would it take you to? That's a part per trillion, just about. That's the minuscule amount that we're looking at when we talk about PFAS. That helps me understand and contextualize just just how small of a concentration we're talking about when we do talk about this. So with that intro to PFAS, we're going to talk a little bit about the regulations around PFAS, where they are today and where they're headed. And for that, I would point you to the EPA, the United States Environmental Protection Agency. They have a PFAS strategic roadmap that they have outlined where they're headed, what they're looking at, and how they plan to regulate PFAS. We're not going to go into all of these. I would advise you to go look that up. They have some great documentation on that that's easy to understand. What's important here on this slide is they have been sticking to their milestones, more or less, and continuing to develop the science behind PFAS, understanding it, and then the regulations that then come from that understanding. And I've highlighted three very important aspects of those regulations that have very wide-ranging impacts. And so back in their roadmap, they had identified summer of 23 to be the time when they want to finalize a CERCLA hazardous substance designation for two compounds in particular. These are the two I talked about, PFOS, PFOS, and PFOA, PFOA. They haven't done that yet. They have proposed the rulemaking for that. It hasn't been finalized. And they've added a few other constituents to that. but I want to highlight that one, and we're going to talk a little bit about why that one's so important. And then fall of 23 obviously has come and passed, but they want to finalize PFOA and PFOS, maximum contaminant levels, MCLs. Those are drinking water limits for all intents and purposes. Got a footnote there. They've added 4 other constituents to those 2 of greatest concern. They haven't been finalized yet. They have been proposed. It has gone through the comment period. And it sounds like maybe by the end of the year, early next year, they plan to finalize those MCLs, and that's the time at which all drinking water systems would have to comply. And we'll talk about why that's important and how big of a deal that is. And then lastly, winter of 24, sometime next year, they want to finalize a risk assessment for PFOA and PFOS in biosolids. And for us wastewater folks on the line here, we'll talk about why that is such a big deal and what's still unknown around that. We're going to continue at a breakneck pace here because there's a lot of information and we don't have a ton of time to talk about it. But I do want to lay the groundwork here for those drinking water MCLs that we talked about. Under the Safe Drinking Water Act, there is a regulatory process that starts with a contaminant list, and then in the orange boxes on the bottom left here are the UCMR program, the Unregulated Contaminant Monitoring Rule. These are contaminants of emerging concern, unregulated. They don't have limits yet, that the EPA is starting to sample for and understand so that they can develop regulations for those. And the reason why I want to highlight the UCMR program is that's ongoing right now for the next 3 years. EPA has released 2 quarters worth of sampling data to the public out of the 12 quarters over the 3-year program, where they're sampling for PFAS nationally. And of those 2 quarters, this is as of last month, looking at that data set, what it tells us for drinking water systems, for small systems, 0 to 10,000 customers, and there's transient and non-transient communities there, about 1 in 10 systems come up with concentrations above proposed MCLs, which is 4 parts per trillion, proposed MCLs for PFOA and PFOS. In total, about 1 in 10 small drinking water systems nationally. For large drinking water systems, PWS, public water systems, that's about 18%, almost 1 in 5 systems nationally exceed those proposed MCL limits. So once those are adopted, that becomes a big issue for these roughly 10 to 20% of drinking water systems nationally. Here at EEC, we took that data set and we wanted to see what that looked like nationally across the nation with our GIS. We put that into our GIS. This is a representation of the first data set. I haven't crunched it for the second that just dropped. But this gives you an idea. I like this map. All the green dots are all the systems that were sampled, and all the red dots are those systems that came out above the proposed MCLs for PFOA and PFOS. What is so useful about this map is it shows that this is heavily concentrated in large urban and metropolitan areas. You'll see some of those major cities throughout the US have some of those pink dots right over them showing that they're exceeding the proposed MCLs. It doesn't by any means mean that this is not a rural issue. Like we said, 1 in 10 small drinking water systems look like they have impacts above proposed MCLs. It's still a rural issue, and we'll talk about how to identify or know if that is likely the case in your area if you're a small system. But I also like that map. It shows it's a national problem. This isn't just concentrated to one area of the nation. We talk about those MCLs, those drinking water limits, maximum contaminant limits. Maybe they're adopted by the end of the year, maybe early next year. We expect it soon though. And once that's adopted, that sets into motion a number of actions, if you will, for drinking water systems that exceed those MCLs. The EPA has, in their Safe Drinking Water Act, you have 3 years to comply with those MCLs to serve water below the MCLs to your customers. May sound like a long time, but what I want to talk about here on this slide is there are a lot of actions that need to happen between when those MCLs are adopted and the 3 years you have to comply that need to take place. You need to test, you need to sample, you need to understand if you have an impact, and if you do, you need to plan for what that impact is. Do you need treatment systems? Do you need blending options? Do you need alternate water options? Then if you are going to put in treatment, you need to design those treatment systems. Maybe you do it internally, or maybe you have a consultant put that design together. Maybe you go out to bid too. You have a period for bidding that. You have a procurement stage for any treatment system components that need to be put in place, particularly pressure vessel treatment. If you need those pressure vessels manufactured, those sometimes have a lead time of 18 to 24 months in some areas of the country. And then you have to build the system, which may, depending on the scale and size of the system, may take 6 to 18 months. You put all that together and suddenly those 3 years are gone pretty quickly. There may be an option to extend that an additional 2 years per the regulations, but what I want to talk about is act now, don't wait. This is gonna, if it is an issue for you, it's going to continue to compound as more and more systems need to be built. The resources, we hear about supply chains all the time. The supply chains for those treatment systems are just going to become more and more impacted as this becomes a bigger and bigger issue nationally. What are those MCLs? I touched on it a little bit. The drinking water standards for that the EPA is proposing to set, these proposed MCLs. I have them listed at the bottom of the table here. To date, some states have been out ahead of this, ahead of the US EPA, the federal EPA. And I've listed some of those state-specific MCLs. And for those of you that have already been dealing with this, maybe you lie in maybe you're in one of these states. It's not a comprehensive list. These are just some of them. But what I want to show here is the proposed MCLs by the EPA in many cases are far below what some of these state MCLs are. And it may not seem like a big difference to go from 20 to 4, but remember, we're talking about parts per trillion. That's a 5-fold factor. Even that is a big difference. And an MCL of 4 is potentially going to be difficult to comply with or maintain compliance. And we'll talk about what that looks like from a treatment standpoint. And then above and beyond PFOS and PFOA, there are 4 other constituents, PFNA, PFHXS, PFBS, and GenX, that have proposed MCLs under a hazard index. I'm not going to go into the details. You can look that up on the EPA's website of how to calculate that, but I've listed those here for you. One other major regulation that, thinking back on the PFAS strategic roadmap that I highlighted, is this potential CERCLA designation as a hazardous substance for PFOA, PFOS, and potentially other PFAS constituents. I've listed here in the hexagon some of the industries or some of the entities where this is going to become the biggest issue for them. That's anything from water treatment plants, wastewater treatment plants, anybody who has PFAS-laden waste streams that are known to contain PFAS. Once that waste stream is designated as a hazardous waste, that becomes a big issue in terms of cradle to grave responsibility under CERCLA from the moment you produce that or you handle that hazardous substance until its final resting place, its grave, disposal, or ultimate destruction of that. Under the CERCLA program, you have full liability for that. It's going to increase cost of disposal. Maybe PFAS-laden waste you're able to dispose of at a non-hazardous facility. Today, you may not. And so if you have to dispose of that at a hazardous facility, transportation and disposal costs will increase. And then there may be other COCs in there. These are like contaminated sites that maybe have received closure previously that now may be reopened because PFAS is suddenly a hazardous substance, or it may be a co-contaminant with an existing cleanup site that needs to be reassessed and redesigned for the remedial solution for that. There's a lot of implications that come along with a CERCLA designation. We don't have time to go into all of them today, but I wanted to touch on that because it is so important. This has been a lot, so I just want a quick recap. What are the key takeaways here? Drinking water MCLs are, for all intents and purposes, imminent, and when you have 3 years to comply. So act now, don't wait. This is something that we're going to have to deal with, small and large systems alike. That's the impact side of things, 10 to 20% nationally, small and large. Small 10%, large closer to 20%. It's a problem for everyone across the nation. And then there are still unknowns. There are still regulations pending or in the future proposed regulations that haven't come through yet. And the cost impacts of complying with those regulations still are largely unknown. How do we comply with those regulations, or what do those regulations require us to do? A lot of that is sampling, characterization, analysis. We're gonna speed through this, so hang on here, stay with me. But I want to talk about, where is PFAS? How do we find it? How do we sample for it? How do we understand it? This is kind of the environmental cycle of PFAS. This is a great graphic that New Jersey Department of Environment put together. A lot of states have similar graphics. What I want to kind of identify for you is, in a lot of ways, wastewater treatment plants, for us wastewater folks online here, are the center in a lot of ways of the PFAS universe. You have domestic and industrial contributions coming in. You have biosolid application maybe to ag or to landfills. You have leachate coming back to the treatment plant from that. You have MPDS discharges to surface waters or ocean discharges. All of PFAS may be present in any or all of these streams, and it just becomes ubiquitous throughout the environment. And so this is what I want to drive home, is kind of wherever we look for it, we tend to find it. It's not the case across the board, but in many cases that is true. PFAS is so ubiquitous because it was used in so many consumer products and processes and chemicals that it is everywhere, and it's becoming a large issue for us to handle. The good news is some states, like I said, have been out ahead of this. One in particular is the state of Michigan. Michigan Eagle, the Environment, Great Lakes and Energy Department, their environmental department at the state of Michigan there, has done a lot of sampling. So if you're looking at doing characterization sampling, don't start from ground zero. Look at those who have done it before you. Find some lessons learned there. And one lesson learned here is, if you're looking at what are the potential sources in my community of PFAS, whether it be to drinking water, wastewater, impacted sites, what are the potential sources? They've done a ton of sampling. They've done a ton of analysis around this. This is just one thing that you can glean from all of that, is what are the most likely sources in my community? This may be in urban areas, or maybe you're a rural area with one large manufacturing site that is a major employer in the area, but maybe it falls under one of these categories as a likely PFAS source. And I've highlighted some of the concentrations found at some of these industries. This is certainly not at every single metal finisher, every single laundry. It's a range too. But what I've highlighted is, if you want to be smart about sampling, go and look at the most likely sources first, and you may be pleased with what you find, and it may become a much simpler problem for you, if you will, to address. How do we analyze for this? What are the methods available to us? I'm going to touch very lightly on this. There's a lot that goes into this, and we could have an entire another session on the analytical methods. But for drinking water, there are two primary methods, method 537.1 and 533. These are the two laboratory methods being utilized by the EPA under the UCMR 5 program that we talked about, the National Sampling Program. They're utilizing these methods for drinking water samples. And then on the wastewater side of things, there's the draft method 1633, which is already being widely used. It's still a draft method. It hasn't been promulgated yet, but it's for non-drinking water matrices, in particular wastewater, soil, sediment, groundwater. What I want to highlight is there's 40 compounds we can sample for. The two drinking water combined, we can maybe get 30, under UCMR 5, they're doing 29. We could get 30 compounds there. Wastewater side, we've got 40 compounds, 30 to 40 listed compounds that we get measurable concentrations for out of 5,000, right? So what we're talking about is tip of the iceberg here. There are other analytical methods that help us kind of understand how much of that iceberg is below the water surface. That's the top assay. These are precursors. I won't go into exactly what that is, but the PFOA, PFOS that we're most concerned about, these are terminal compounds. They have other compounds that are called precursors that ultimately break down in the environment into those terminal compounds that no longer break down. We can identify some of that, or how many precursors there are through this top assay analysis. The other one's draft 1621. This is total organofluorine assay, TOF. What this measures, it's an indicator analysis that measures all fluorinated chemistry within your sample. So like I said, it's tip of the iceberg. We're here on the Titanic, the proverbial PFAS Titanic. We have a couple of tools available to us. Say we take a hypothetical wastewater treatment plant influent sample, and we run it through 1633, analyze for 40 compounds. We may get, and add those all together cumulatively, we may get around 100 parts per trillion. Maybe it's 40, maybe it's 400. Magnitude of 100 parts per trillion. If we run the top assay analysis on that and look for those precursors of those 40, we may get somewhere cumulatively on the order of 1,000 parts per trillion, an order of magnitude greater. And you run 1621, this indicator analysis, you may get something like 10,000 parts per trillion. That may be a lot of PFAS, it may be other fluorinated chemistry in there. It's an indicator, but it kind of helps us understand how much PFAS is there, whether we can quantify it into specific compounds, specific chemical structures, or if it's just more part of the general PFAS class of constituents. That's a lot. Let's recap here. Let's pause. Let's take a breath. What's important? Look at source. Source identification is crucial. If you have a PFAS problem or impacts, let's see what are the sources that are causing that. There are some sampling analytical methods available to us for drinking water and wastewater, but understand it may only show us a portion of the overall picture. It's good enough, it shows us enough to comply with regulations today, but where are those regulations headed? And then understand that it's ubiquitous. It's all throughout the environment, so it's not going to be a one-size-fits-all solution to deal with PFAS. You may need a toolbox approach. And let's talk about what some of those options, treatment options that are available to us. I'm going to go even faster through this. We could do multiple presentations on these treatment options, but what I want you to take away from this, if you're a drinking water system, small or large system, there are mature technologies available to you should you have PFAS impacts that can be implemented and treat to non-detect levels to comply with these MCLs. That's what I want you to understand. There are technologies available, you can implement them, and you can treat for PFAS. All right, so some of the most common technologies or the best technologies, lowest cost and highest removal efficiency technologies off to the right of this graphic, great graphic that Corolla put together. Granulated activated carbon and ion exchange. These are adsorption technologies. I won't go into all the details, but GAC and ion exchange are pressure vessel treatment systems that can be readily deployed and implemented to treat for PFAS and have been demonstrated to effectively treat for PFAS. RO also does, reverse osmosis, that's membrane technology. Less common to be used on drinking water systems. It may be the solution for wastewater, and we'll talk about that. I put here some pros and cons. I won't go into all of it, but like I said, GAC and ion exchange can be implemented readily. They do provide effective treatment for various constituents that can be analyzed for. And there are some pros and cons in certain scenarios where you may choose one over the other. Like I said, membrane, that's a higher cost option for drinking water systems. And the big thing to remember about membrane systems or RO systems is you do still have that liquid waste stream. You pass the water through a membrane, clean water goes out, but you still have that concentrated waste stream to deal with. And the question then is, how do we deal with that? I'm a visual guy. I like to understand what is GAC, what is this carbon ion exchange resin. These are just some pictures, and I'll lump novel adsorbents in here too. This is an emerging technology that acts in a similar way to GAC and ion exchange. It's an adsorptive technology, but it is demonstrated to be more selective towards PFAS treatment, and that has a lot of benefits. But GAC are, more kind of like, think of it like charcoal, granulated activated carbon. Ion exchange are these little tiny resin beads, and then novel adsorbents like fluorosorb. I have a picture here. You put these in media beds within pressure vessels. This is a picture of a pressure vessel treatment system we put in here in Southern California. And so they have a bed of media inside of them that the water runs through. You put them in this lead lag configuration. Here's an example if you have a wellhead treatment system, what that might look like from a process flow standpoint. You have your existing well, maybe you went straight from well to distribution with disinfection previously. Now you're going to add on this pre-filtration, these lead lag pressure vessels loaded with either carbon, GAC, or ion exchange or novel adsorbents. Again, we could spend an entire hour on this, but I just want you to know there are technologies, we do know how to implement those, and we can treat for PFAS with those technologies on the drinking water side. For all you wastewater folks out there, let's touch on that a little bit. The regulations are starting with drinking water, and then logically, as you move up the environmental chain, that drives drinking water sources like surface waters or groundwater, that drives discharges to those sources like MPS discharges from wastewater treatment plants or reinjection into aquifers like we do here in the Southwest. So this is largely at treatment plants driven by MPS limits. That is the limits on the effluent going out of your wastewater treatment system into the environment, whether that's to a river or an ocean or something like that. There are only a few places that currently have MPS limits. That is going to change as drinking water MCLs are adopted, and then the cascading affects the dominoes, the regulatory dominoes from there. But that's the driver for a lot of these treatment plants. And what I want to talk about and focus on here is if you are a treatment plant, if you have an MPS permit limit that you have to comply with, and you want to understand how to comply with that. Again, I'm going to point towards Michigan because they've done the most around this issue. They have MPS limits at some POTWs in Michigan, and they have had success meeting those limits in many cases by controlling the sources. We talked about look for those sources in your community, whether it's an industrial source or not, and how to regulate upon those to control what's coming into your plant so that you can control what is going out of your plant. And that's done through pre-treatment programs, source investigations, technically based local limits. I'm not going to go into all of that, but it's very complicated. But the good news is, in many cases, by controlling those sources coming into your plant, you can reduce PFAS coming into your plant and thereby reduce what's going out of your plant. Why is it such a big concern at treatment plants, or the kind of bullets towards the bottom here? Land application of biosolids. A lot of plants throughout the nation have great biosolids programs where they land apply to agricultural, or maybe you're landfilling your biosolids too. But that becomes a big concern with a potential CERCLA designation for this, or maybe we're just spreading PFAS throughout the environment is a big concern. So that needs to be looked at and studied better. And then recycled water programs. If you have a water reclamation facility or you're treating to Title 22 standards and applying purple pipe irrigation, recycled water throughout your community, that is potentially PFAS laden streams that are then spreading PFAS throughout the environment. That's something that needs to be further studied and understood. And then treatment options at the POTW are much more complicated than drinking water. Won't go into all of that. But the big takeaway here is looking at Michigan. This is a GIS that they have of all their POTWs that they sampled under this program, where they had great success reducing the influent sources and therefore the effluent. All those green dots are plants that are currently discharging below their water quality standards. The blue dots I've highlighted are the ones that are a little more complicated, and this comes down to whether those influent sources are controllable industries that have permits that you can have them put in treatment for, or uncontrollable sources like residential or commercial. Again, it's just a very complicated issue. It requires more studying. It requires more knowledge base around it and developing those solutions for it. Quickly touch on some disposal options. We talk about if we do treat and we use media like GAC or ion exchange, well, that just captures the PFAS. What do we ultimately do with that, right? We haven't destroyed the PFAS. We've just concentrated it. We've captured it. So you may landfill it, but now that may be hazardous waste landfill. May go to incinerators, but are those incinerators burning hot enough for ultimate destruction of the PFAS, or is it breaking it down into smaller PFAS compounds? On-site destruction is an emerging technology and is being implemented at larger and larger scales throughout the US. And I'll talk about what a couple of those are, and then maybe on a case-by-case basis, deep well injection. Again, I'm not going to go into all of those, but one thing to be aware of when it comes to PFAS disposal is not spreading PFAS, but being smart about it and ultimately properly disposing of it or destroying it. One thing to be aware of in PFAS destruction is, are we ultimately destroying it? That's being looked at, particularly on the incineration side. Are we achieving full destruction, or are we just breaking it down at incinerators? Are they burning hot enough to facilitate that ultimate destruction? It's the carbon-fluorine bond that needs to be broken. This just talks about some things to look out for. And then PFAS destruction technology, I said these are emerging technologies. You'll see a lot of shipping containers in these pictures. They're being scaled up quicker and quicker, and a lot of money's being spent to research this. These are a couple of those emerging technologies that are showing promise for ultimate destruction of PFAS. And so a lot of cases, these are pilot scale, they're being scaled up. They're in a lot of cases, low flows and high concentration of PFAS. We would love to flip that, where if it's high flows and low concentration, we can still destroy it. That's more readily implemented at something like a treatment plant. But there is a lot of promise around here and around this area of ultimate destruction, oxidation technologies, and they're continuing to evolve. Let's all breathe. This was a lot. And I want to recap kind of the quick takeaways. There's a lot of technical stuff in here, a lot of mumbo jumbo, a lot of letters, alphabet soup type of stuff. For those of you who are attending and are walking away from this, what do I want you to walk away with? There are existing treatment technologies, best available technologies that can treat for PFAS that are mature technologies. They've been established, they've been demonstrated as effective technologies, particularly on the drinking water side, which is the next regulation to follow, which is the proposed MCLs soon to be adopted. The difference between water and wastewater, I put simpler here, maybe that's oversimplifying it, but water is simpler because we have these established technologies that have been demonstrated. Wastewater, due to the nature of wastewater and the competing anions and organic chemistry in there, treatment of wastewater is a more complicated situation, and it's continuing to evolve and being looked at. And then the ultimate disposal, destruction, how do we get away from PFAS in the end, is ultimately by destroying it, inerting it, mineralizing it. Those technologies are continuing to be developed. It can be a complicated issue though, and we're looking nationally, universities and the EPA and agencies are looking at this and developing that science and guidance around it. The last option, if you do have to address PFAS, What are the options available to me for funding that? Especially for small systems, you may not have the capital readily available to do so. Luckily, there are some funding options, particularly from the bipartisan infrastructure law that was put into place. There's been an allocation of billions of dollars. I believe it's 9 billion total, and 2 billion have been greenlit for distribution for PFAS projects to assess and treat for PFAS. There may be grants to that effect. There may be grants or low interest loans available to communities, especially disadvantaged and small communities. That may be on a state by state basis. There may be local agencies that distribute that funding, particularly at the state level, state revolving funds. There may be funding available to you for these types of projects. And then litigation and cost recovery. You may have seen headlines in the news about the 3M settlement, the $10 billion settlement for public water systems nationally to fund treatment for impacted systems. There may be options there through litigation or cost recovery to fund those projects. And then I would encourage you again to lean on the EFC, the Environmental Finance Center Network, and your local chapter to advise you. They have, I put a link here, a great page that you can go and select your state, and they have a table of all these funding options available to you state by state. So big takeaway, act now, don't wait. Let's get started figuring out if we have an issue, how big of an issue that is, and what's available to us to address that. So that goes with the assessment and the treatment of it. And then leverage EFC to help you along the way. They have a wide range of resources available to you, educational resources, funding resources. Leverage those folks at the EFC. So that'll do it for me for presentation. I wanted to leave some time. Looks like we've got about 9 minutes for Q&A, maybe a couple quick hit questions from the audience here, if Maya can help us out with that.
Yeah, so we do have a handful of questions. Let's see. First one, ultimately, why is PFAS harmful or dangerous?
Great question. There have been a lot of human health studies done around PFAS, and what they have found is that it is correlated with, and they have found that it causes cancer in many cases, or it's an endocrine disruptor, or it has impacts to fetal health for pregnant women, premature births, things like that. So there are these negative human health impacts that have been established and correlated to exposure to PFAS in humans that have led to and informed the proposed regulations that the EPA is setting.
All right, thank you. Next question. Are the chemical manufacturers responsible for PFAS being assessed a financial surcharge to pay for the cost of treatment?
I would say that there is litigation going on around the manufacturers of these chemicals. And like I mentioned, the settlement with 3M might answer your question where, yes, they are paying for assessment and treatment of PFAS for drinking water systems nationally. They have not admitted to wrongdoing as a condition of that settlement. I'll be a little political in my answer there.
All right. Next one asks, is the waste from treatment considered hazardous?
Currently, no, because there is not a CERCLA hazardous substance designation for PFAS. If you have PFAS-laden waste, you may find, as you try to dispose of that waste, that non-hazardous landfills are not accepting it in many cases, and your only option may be to dispose of it at hazardous landfills because of the concern of a pending CERCLA designation.
All right. Next question. Will the EPA designated MCLs be the baseline States can make more strict regulations, but not less strict, right? Question mark.
That's correct. Yes, so states can elect to set MCLs lower than the federal EPA, but they must be as low as the federal EPA. So across the board, and again, some states haven't done anything proposed or adopted in terms of drinking water MCLs. Once the EPA adopts those MCLs, every state is going to have to comply with at those limits or stricter than those limits.
All right, next question. Are PFAS chemicals still being used?
Yes, there has been a ban on PFOA and PFOS in the US and in many places in Europe, but those are just 2 out of 5,000 chemicals. In a lot of cases, those have been replaced with second or third generation PFAS chemistry, different PFAS chemicals that act in the same way or even better than some of those original PFOA and PFOS chemicals. And some of those substitutions we may not be able to detect with our current analytical methods and the analyte lists available to us. That's why I identified some of those other analytical methods that give us an idea of what's below the waterline on that iceberg. We're still learning.
All right, thank you. Next question. Are there any proposed MCLs or other limitations on the level of PFAS in biosolids or land application?
Yes, I don't believe they're called MCLs in that scenario. I would look as an example to the state of Maine has banned agricultural land application of PFAS-laden biosolids across the state. So that has become a big issue in the state of Maine of what to do with those biosolids. They're figuring it out ahead of many other states. Some of it goes to Canada, some of it goes to nearby states that are accepting it. But yes, there are limits to that. And no, there are no official federal regulations around that yet.
All right. Next question. Is the timetable for developing the plans and implementation the same for small and large systems?
Probably not. And a lot of that comes down to design and procurement and build of those systems. For small systems, that's a much smaller system. That's a lot less equipment that needs to be procured and built. And so therefore the timetables for those are shorter. I gave kind of a range of what that would look like. So it just depends on the scale of what you're doing. For example, the pressure vessels, the pictures I had, those are 12-foot diameter vessels. 2 of those is a single train, and typically that can treat around 1,500 GPM. And you can scale that up, put 2 more, 3,000 GPM, 45. And then you can scale those vessels down for smaller flows.
Thank you. Next question. When you talk about regulating the PFAS coming into wastewater treatment plants, are regulations expected to be on the effluent leaving the plant?
That's likely where they'll start. Yeah, you'll have an effluent limit that you as a POTW need to comply with, and then you need to figure out how to meet that. And what that looks like is identifying the sources coming into. You're not generating PFAS at the plant. It's coming in, you're receiving it, and then sending it out because there's no removal efficiency at a plant. So then how do you regulate those controllable sources, the industries that send PFAS-laden waste streams to your plant, or is it coming from a domestic uncontrollable source is what it's called? That whole process in and of itself is fairly complicated, and there's a lot around that. But it starts with the effluent limits.
All right, the next question asks, do you know if GAC installed treatment systems produce a solid waste byproduct?
Yeah, so eventually you'll use up the treatment capacity of the GAC. It can no longer absorb any more PFAS onto the surface of those individual pieces of carbon. Once that is the case, you get breakthrough of PFAS. You're testing the effluent of it. When you get the breakthrough and you're no longer non-detect, then you need to switch out that carbon bed. You dewater it, you take all that used spent carbon out and you load it with new carbon. Now that spent carbon that you have to figure out what to do with it. And that is either incineration or landfilling at a non-haz or a hazardous landfill. That's all subject to pending regulation.
Perfect. Next question asks, are there any reliable methods for source tracing of PFAS leading into wastewater treatment plants?
Yeah, so this is collection system characterization is what you would call this. And that has to do with taking samples within the collection system, knowing what is coming to each individual pipe segment or manhole, whether that's purely a residential source or whether there are industries that discharge to that location, being strategic about what manholes you sample at so that you can identify those sources within your collection system and parse that out, taking multiple samples throughout your collection system, looking at what the results are and what the waste streams were contributing to that, and parsing out all that data.
Thank you. Next question asks, kind of a two-part question. The first part asks, is air regulation coming as well? And is adverse impact to human health different if exposed by air or in drinking water?
It's a good question. I'll ask you real quick, Maya. We did hit 11 o'clock. So do we have time to answer this?
It's totally up to you. If you have other commitments, we can absolutely address these after the webinar, but it is totally up to you. I'm willing to stay on for another minute or two if you are, but if you have other commitments, that's totally understandable.
That's fine with me, and I'll answer it to the best of my abilities. There are not currently federal regulations around air quality for PFAS. Like I said, certain states may be regulating that, like the state of Illinois has banned incineration of PFAS due to these concerns about aerial deposition of PFAS from incomplete combustion and destruction of that PFAS at incineration facilities. And then the human health impacts of ingestion of water that is contaminated with PFAS versus air. I am not a toxicologist. I'm not an expert on that. I know it is being studied and it is still being figured out, the total impacts of that. And I would encourage you to go and research human health studies around PFAS ingestion of water versus air. I'm not an expert on that though.
All right. I know we are over time for everybody who is attending and needs to log off for another commitment. But thank you everybody for sending in your questions. Will, do you have anything else to add for today?
I think that's it for me. Yeah, I'm sure there's any one of these slides could be another hour session. There's a lot to it and it's very technical, but I thank you. I just want to add thank you to the EFC for hosting us, the Southwest EFC as well that pulled me in on this. And thank you to all of you who attended and listened to what may have been the equivalent of drinking from a fire hose.
Well, thank you, Will, for sharing your expertise with us today. As far as for everyone following this webinar, you will receive a follow-up email with the slides from today, as well as a link to the recording. We also ask that you complete the webinar evaluation following the webinar so you can let us know your thoughts on today's session, as this helps us plan future webinars on topics important to you. Thank you all again, and thank you, Will. We hope to see you all at future EFCN events.
Thank you. Have a great day.